in this problem, it says, assume that females have pulse rates that are normally distributed with a mean of mu equals 76 beats per minute and a standard deviation of sigma equals 12.5 beats per minute. So in the first part, it asks if one adult female is randomly selected, find the probability that her pulse rate is less than 82 beats per minute. Because we're talking about one individual, we're finding the probability that an individual value is less than 82 when we have a mean of 76 and a standard deviation of 12.5. So to calculate this probability, we're going to use the normal CDF function in the calculator because we're looking at this normal distribution. The mean is 76, and we're looking for the probability of getting an individual value less than 82. So we are going to put in the left boundary, or our lower boundary, and that's going to be negative 1 E99 because there is no lower boundary here. It just says less than 82. I'm just going to take this out to make space. My upper boundary is the 82. The mean is 76, and the standard deviation is 12.5. So when I press enter, I get 0.6844, and that's rounded to 4 decimal places. So that's how I do that problem. Now in this next problem, it says, what if 16 adult females are randomly selected? Find the probability that they have pulse rates with a mean less than 82. So now we're finding the probability that the mean of the values is less than 82. So again, I'm going to use my normal CDF function. And again, we're going from negative 1 E99, and I can use the 1 or not. So either 1 E99, negative 1 E99, or just negative E99. Either one is fine. Make sure that this negative is the negative in parentheses on your calculator. And my upper limit is 82. Now, because we're looking at a sample mean, we need to know mu sub x bar, which is just mu, so that's 76, and sigma sub x bar, which is sigma divided by the square root of the sample size. So that's going to be 12.5 over the square root of the sample size, which was 16. And when you work that out, you get 3.125, or you can just type it in that 12.5 divided by the square root of 16. So either way, because sometimes these don't work out to nice numbers, and we don't want to have to round. In this case, we wouldn't have to, but you can just type in that calculation for the standard deviation. And then you get 0.9726, and that is your answer for part B. So that's how you do those problems.